In the serene expanse of Yellowstone National Park, where geysers dance and wildlife roams free, a terrifying tremor ripples through the earth, shattering the calmness of this natural wonderland. What began as a faint rumble has escalated into a relentless onslaught of earthquakes, each one more powerful than the last. But what lies behind this unprecedented surge in earthquakes? And why are hundreds of thousands of people fleeing their homes in a desperate bid to escape the looming catastrophe? Join us as we unravel the earthquake at Yellowstone that has left hundreds of thousands fleeing their homes. Secrets of a sleeping giant. Few places on Earth compare to Yellowstone Park. It's packed with history and breathtaking landscapes. You can explore endlessly here. But while everyone marvels at the pretty canyons and geysers, something dangerous brews beneath the surface. It's so secretive even the government keeps quiet. But Anonymous, the infamous hacker group, spilled the beans. Yellowstone Park is closed, and weird things are happening. You wouldn't notice it, but right beneath your feet, there's trouble brewing. Yellowstone normally has about 1,500 to 2,500 yearly earthquakes. Lately, they're getting more frequent and closer together, worrying park officials. With such a big volcano, even minor activity can spell disaster. The ground might shift, and the temperature of hot springs could mean magma's on the move. These signs hint at a possible eruption, a catastrophe waiting to happen. And Yellowstone isn't just any volcano. It's a supervolcano capable of global destruction. The caldera at its heart is a giant bowl-shaped crater formed by past eruptions. With all these tremors, it's only a matter of time before it blows. The heat from moving magma affects nearby hydrothermal systems, hinting at what's brewing underground. Monitoring these changes is crucial, but sometimes super eruptions happen without warning. The movement of magma can deform the Earth's crust, shifting hydrothermal features. Chemical shifts in the fluids provide clues, helping officials brace for potential eruptions. But even with their vigilance, super eruptions can surprise everyone. So, the ground beneath our feet might be more unstable than we think. As magma rises, it heats up and affects the nearby hydrothermal systems. It's tricky to measure these changes because temperatures have been fluctuating due to climate change. However, researchers have noticed a sudden increase in recent years. Geysers, famous for their periodic eruptions, are especially sensitive to disturbances underground. Changes in geyser behavior, like eruption intervals and intensities, indicate something big might be brewing, a supervolcano eruption rather than a normal one. There's also been a rise in gas emissions, particularly sulfur compounds within Yellowstone. The smell of rotten eggs, caused by hydrogen sulfide, is a concern as it's linked to magmatic activity. Monitoring gas emissions is crucial for detecting volcanic activity, even without earthquakes. But earthquakes play a big role too. The Yellowstone caldera formed from 3 massive eruptions over millions of years, each incredibly destructive. The epic eruptions of Yellowstone. Around 2.1 million years ago, the Huckleberry Ridge eruption occurred, marking the largest of the 3 major eruptions. It spewed out approximately 2,500 cubic kilometers of volcanic material, forming both the Island Park caldera and the Huckleberry Ridge tuff. Following that, about 1.3 million years ago, the Mesa Falls eruption took place, the smallest among the trio, with a volume of 280 cubic kilometers. This eruption shaped the Henry's Fork caldera and the Mesa Falls tuff. The most recent full-scale eruption in Yellowstone, the Lava Creek eruption, happened approximately 640,000 years ago, resulting in the formation of the Yellowstone caldera and the Lava Creek tuff. The Lava Creek eruption emitted roughly 1,000 cubic kilometers of ignimbrite, a type of hardened volcanic material. This term originates from Latin words meaning fire and rain, reflecting the fiery nature of volcanic activity. It's staggering to envision a 1,000 cubic kilometer mass of fiery debris raining down, capable of incinerating all living things nearby. However, what's even more terrifying is that this eruption was categorized as a huge super eruption, dispersing volcanic material like ash across the United States. The term huge is relative, especially when discussing the largest and most powerful super eruptions in our planet's history. These cataclysmic events occur when magma from the mantle rises into the crust but fails to break through, resulting in the accumulation of pressure and the potential for a super eruption or the formation of a supervolcano. Such large-volume supervolcanic eruptions are often associated with expansive igneous provinces that can blanket vast areas with lava and volcanic ash, leading to significant climate change, including the initiation of small ice ages and threatening various species with extinction. Volcanic eruptions are classified using the Volcanic Explosivity Index, VEI, a scale indicating the explosiveness of an eruption. Over the past 132 million years, there have been around 40 megacolossal eruptions with a VEI of 8, 30 of which occurred in the last 36 million years. One notable event is the Toba eruption, which occurred approximately 74,000 years ago. This eruption, forming the Toba caldera complex in North Sumatra, may have triggered a volcanic winter lasting over a decade and possibly initiated a 1,000-year global cooling episode. Volcanic winters occur due to volcanic ash and sulfuric acid blocking the sun's rays, leading to reduced global temperatures. These long-term cooling effects are mainly influenced by the injection of sulfur gases into the stratosphere, where they undergo reactions to form sulfuric acid aerosols. Some researchers believe that such volcanic events could have caused population bottlenecks, resulting in sharp decreases in species populations, followed by genetic divergence among survivors. The Toba event could have reduced the global human population to as few as 15,000 individuals. Some genetic evidence suggests that modern humans are descendants of a small group of between 1,000 and 10,000 breeding pairs that existed around 70,000 years ago. However, the idea of an October catastrophe theory linking the Toba event to a genetic bottleneck has faced criticism. A more suitable name might be the Toba catastrophe hypothesis, as there's not enough evidence to support it as a credible scientific theory. The Toba super eruption expelled a volume of 2,800 cubic kilometers of material, significantly larger than the Lava Creek eruption of the Yellowstone supervolcano. Additionally, the Toba eruption released about 4 to 6 billion tons of sulfur dioxide into the atmosphere. Despite its magnitude, the Toba eruption pales in comparison to some of the largest volcanic eruptions in history. The La Garita caldera, located in the San Juan volcanic field in Colorado, is one of the largest and most powerful volcanic eruptions known in Earth's history. Formed about 28 million years ago during a massive ignimbrite flare-up, the La Garita caldera is one of several calderas in the region. The eruption devastated a significant portion of what is now Colorado, with the resulting Fish Canyon tuff covering an area of at least 28,000 square kilometers. In terms of volcanism scale, the La Garita caldera ranks as one of the greatest of the Cenozoic era. The Fish Canyon tuff had a magma volume of about 5,000 cubic kilometers, 5 times larger than the last full-scale eruption of the Yellowstone supervolcano. Signs of an impending danger. Yellowstone has already covered the initial signs of a looming supervolcano eruption. Typically, these signs include a notable increase in seismic activity, marked by a series of earthquakes of varying strengths. These earthquakes indicate the movement of magma and adjustments in the Earth's crust due to mounting pressure. Since March 2018, there has been a noticeable shift in Yellowstone's volcanic behavior. The once rare eruptions of the renowned Steamboat Geyser have become more frequent, occurring as often as once a week. This surge in activity is unprecedented, lacking any historical precedent or documentation. In 2014, an earthquake measuring 4.8 on the Richter scale struck near the Norris Geyser Basin, an area with minimal seismic activity in the park's northwest corner. This event raised significant concerns due to its rarity. But what would happen if Yellowstone actually erupted? Contrary to regular volcanic eruptions we see today, a supervolcano eruption like the one that could happen at Yellowstone is on a whole different level. If Yellowstone were to erupt, the initial blast would be like setting off numerous atomic bombs all at once. The explosion would release an immense amount of energy almost instantly. This energy forms a powerful shockwave that spreads outward from the eruption site, interacting with everything in its path. This interaction causes a sudden and extreme increase in pressure, leading to widespread destruction. Walls, roofs, and windows could buckle and shatter under the pressure. Even sturdy structures might struggle to withstand the force. Trees might bend under the shockwave's energy, but even they could be uprooted or snapped. In a national park like Yellowstone, this would be catastrophic. But the scariest part isn't just the explosion itself. When a volcano erupts, it spews out a mix of molten rock, gas, and ash from deep within the earth. The scale of a supervolcanic eruption, like one at Yellowstone, can be so massive that much of the material might not even travel far from the crater due to gravity and the eruption's sheer force. Despite this, there's still a chance of some lava flows. These occur when the erupted magma remains so hot that it stays in a liquid state, flowing like a terrifying river of molten rock. The lava flows during a Yellowstone eruption would likely be slow-moving. This is because the molten rock is very thick, making it resistant to flowing quickly, unlike the fast streams of lava seen in some volcanic eruptions. These Yellowstone lava flows would creep along at a relatively leisurely pace. Now, you might think that's a good thing if you're nearby when it happens. But even then, you'd need to move quickly to escape the lava before it spreads throughout the entire national park and beyond. And that wouldn't be easy. Many factors determine how far the lava flows can reach, like the terrain, how quickly the lava cools down, and the size of the eruption. Usually, these flows would only go about 25 miles from where the eruption started. Still, the lava released during an eruption would be scorching hot, often hotter than 1,832 degrees Fahrenheit. This extreme heat would be a big threat to anything it touches. And it's not just people who'd be in danger. Everything in the national park would be at risk. Even buildings and other structures nearby could be damaged or destroyed if they're in the path of the lava flows. The intense heat could set flammable materials ablaze, and the sheer force of the lava could crush buildings, leading to massive amounts of damage, potentially costing millions of dollars to repair. The hidden impact of Yellowstone's eruption. People often overlook how lava flows can harm the plants and trees nearby. The intense heat from the lava would set vegetation on fire, making the area even more dangerous. Plus, the high temperatures would burn or severely damage any plants in the path of the lava. This would be tough for wildlife living nearby too. Many animals might struggle to run away from the slow but steady flow of lava. As the lava destroys their habitats, local ecosystems would be in danger too. When we think of volcanic eruptions, we usually think of earthquakes and lava. But a massive eruption at Yellowstone would also send a huge amount of ash and debris into the air. This mix of tiny particles, rocks, and minerals would shoot high up into the sky because of the eruption's force. Once in the air, the ash would travel with the wind for long distances, depending on how strong and which way the wind blows. These ash clouds could spread hundreds of miles from the volcano, affecting areas far beyond where the eruption happened. As the ash spreads out, it doesn't just sit there, it interacts with the atmosphere. The tiny particles in the ash can scatter sunlight, making the skies hazy and visibility poor. This could make it hard to travel, navigate, and carry out daily activities, showing that the effects of the eruption reach far beyond the local area and even influence the Earth's atmosphere itself. The ash and sulfur particles floating in the air act like a giant umbrella for sunlight. When sunlight hits these particles, a big part of it gets scattered and sent back out into space. This means less sunlight reaches the ground, making things cooler. This cooling effect happens all over the world and is called a volcanic winter. It's like nature hitting the cool button. The drop in temperature can make both daytime and nighttime feel chillier. And it's not just the temperature that changes. Weather patterns can shift too. Different regions might experience different weather, like more wind or changes in ocean currents. These changes can stick around for a while, even after the eruption is over. But that's not all. Less sunlight hitting the ground can mess with plants' energy-making process called photosynthesis. With less light, plants grow slower. This could mean delays in crop growth and harvest times, which isn't great for farming. These changes in climate and plant growth usually last for a few years to a few decades. This has happened in the past as well. Now it's time for today's subscriber pick. In the heart of Yellowstone, A relentless barrage of earthquakes sent shockwaves of fear rippling through the land. The raging earthquake at Yellowstone left hundreds of thousands fleeing their homes. Sarah, a young mother, clutched her children tightly as cracks tore through their house. With adrenaline-fueled haste, she raced to safety, navigating chaos-filled streets. Meanwhile, scientists at the Yellowstone Volcano Observatory struggled to decipher the unprecedented seismic activity. Dr. Michael Hayes, a seasoned geologist, struggled with the grim reality unfolding before him. As the ground trembled beneath their feet, fissures spewed forth gas and lava, transforming the once serene landscape into a fiery nightmare. In the town of Jackson, Mayor Carter urged residents to evacuate, his voice drowned out by the clamor of panicked crowds. Sarah, her children in tow, fought through the chaos, seeking refuge in the evacuation zone. Beneath the starlit sky, they huddled together, grateful for their survival, yet keenly aware that their battle for survival had only just begun. As Yellowstone continued to rumble with fury, they braced themselves for the uncertain days ahead, united in their determination to endure the tremors of terror. The eruption that changed history. More than 200 years ago, humanity witnessed the most massive volcanic eruption ever recorded. In April 1815, Mount Tambora in modern Indonesia erupted so violently that it made all other volcanic blasts seem insignificant. It ejected over 100 times more debris than the famous 1980 eruption of Mount St. Helens, enough to cover the entire Great Britain with a layer of ash knee-deep. The immediate impact was devastating. Up to 12,000 people died instantly, with another 90,000 succumbing to the aftermath. But Tambora's effects were not confined to the local area. It released so much sulfur into the atmosphere that it cooled the entire planet, leading to what became known as the Year Without Summer in Europe, China, India, and North America. The year 1816 saw endless winter, with snow falling in July, rivers freezing in August, and widespread crop failures causing famine and disease that may have led to the deaths of up to 1 million people. However, amidst this tragedy, the events of that awful year also had far-reaching consequences that shaped the following century. Migration patterns, literature, art, and politics were all profoundly influenced in ways that still impact us today. In all of human history, only a few eruptions have reached the level of VEI 7 on the Volcanic Explosivity Index, indicating massive amounts of debris unleashed into the sky. Tambora's eruption is thought to be possibly the largest since the 2nd century AD and the only VEI 7 event in modern times. What makes Tambora even more remarkable is that before its eruption, nobody even realized it was a volcano. Towering over the island of Sumbawa, Tambora had been seen as nothing more than a harmless landmark, like any other inactive geological feature. But in 1812, everything changed dramatically. In that particular year, Tambora began emitting unexpected noises, signifying the awakening of its dormant power. Looking back, we now understand this period as a precursor to the mountain's cataclysmic eruption, much like a singer clearing their throat before a grand performance. People paid little heed to Tambora's rumblings, carrying on with their lives as usual around the mountain. However, the consequences of their indifference would prove devastating in 1815. At that time, the territory around Tambora was under temporary British control due to the Napoleonic Wars. So, when cannon fire was mistaken for Tambora's eruption, Governor Stamford Raffles mobilized ships, fearing an invasion. But soon it became clear that the mountain itself was the source of the turmoil. The eruption on April 5, 1815, was colossal, heard up to 1,000 kilometers away, and sending ash soaring into the sky for hours. Tambora's initial eruption was like a warm-up before the main event. 5 days later, on April 10th, the mountain unleashed its full fury, blasting off its top and leaving a massive crater. Enormous clouds of debris flooded down the slopes, wiping out everything in their path. Within these lethal ash clouds, massive boulders wreaked havoc, demolishing buildings in seconds. All settlements within a 20-kilometer radius were wiped out, with up to 10,000 people perishing instantly, consumed by the intense heat. Tambora's awakening was relentless, claiming over 90,000 lives before falling dormant again. Its eruption marked the beginning of a catastrophic chain of events that would alter the course of history. After Tambora erupted, it continued spewing out ash and debris until July, a span of 3 months. During this time, the entire surrounding area turned into a continuous nightmare. Thick layers of ash blanketed the island for weeks, choking people and contaminating water sources. Homes collapsed under the weight of the ash, and nearly all forms of life suffered. Crops failed on a massive scale, leading to widespread starvation. However, not everything perished outright. In the stagnant, polluted water left behind by the eruption, tiny microbes thrived and spread, seeking out new hosts across the land. This marked the arrival of another aspect of Tambora's devastation: disease. Throughout the spring and summer of 1815, dysentery spread like wildfire, claiming tens of thousands of lives, especially among those already weakened by the eruption's aftermath. As the situation grew dire, locals fled their homes, abandoning entire villages. Some resorted to desperate measures, even selling their children into slavery to escape the horrors. Governor Stamford Raffles of Java, later known as the founder of Singapore, learned of the disaster and dispatched a team to investigate. Their reports provide crucial insights into the eruption's impact, the global impact of an ancient eruption. By the time Tambora ceased its fiery belching, up to half of its population of 180,000 was dead or missing, making it the deadliest eruption in recorded history. The aftermath led to significant demographic changes when the local sultan resettled Tambora and brought in large numbers of slaves. But the effects of Tambora's eruption weren't confined to just one region. Roughly 6 years prior, in 1809, another significant volcano had erupted somewhere in the tropics. While much smaller than Tambora, it released a substantial amount of sulfur into the atmosphere. Traces of this sulfur can still be found in ice core samples today. This sulfur had a profound effect on the planet's climate. Once in the upper atmosphere, it formed a faint veil that persisted for years, intercepting some of the sun's light and cooling the Earth's surface. These climate changes would have far-reaching consequences. Since the eruption of 1809, the Northern Hemisphere had been enduring one of its coldest decades on record. With Tambora now spewing out even more sulfur, the veil of particles in the atmosphere thickened further. However, the impact wasn't uniform across the planet. When volcanoes in tropical regions erupt, like Tambora, the debris they release disperses into both hemispheres. But the Northern Hemisphere feels the effects most intensely. Tambora's eruption likely cooled the entire planet by about 0.5 degrees Celsius, but Eurasia and parts of North Africa may have experienced a chilling drop of up to 4 degrees Celsius. To put this into perspective, consider that modern climate change activists are deeply concerned about a mere 3-degree increase in global temperatures. By the end of 1815, news of Tambora's eruption had finally reached London, and in the following weeks, ships crossing the Atlantic carried the story to America. Sadly, at the time, people lacked the scientific understanding to comprehend the significance of Tambora's eruption on weather patterns. It wasn't until the mid-20th century that science would advance enough to make these connections. For those living in 1815, hearing about Tambora was merely a distant event in Indonesia, of little consequence to their daily lives. But had they possessed modern scientific knowledge, they would have realized the grave implications. The sulfur veil spread rapidly around the planet, enveloping it in a stifling embrace. Within a few months, this would lead to catastrophic consequences. At the precise moment Tambora erupted on one side of the world, Europe was in the midst of a tumultuous period. It was April 10, 1815, in the middle of what historians call the 100 Days, a time when Napoleon escaped from his island prison and threw Europe into chaos again. By the time Napoleon was defeated at Waterloo in June, the continent had been in constant warfare for nearly 25 years. The economy was in shambles, political tensions were high, and post-war demobilization was leading to widespread unemployment. Into this already unstable situation, Tambora unleashed its cataclysmic impact. The following year, known as the Year Without Summer, began as any other in Britain, cold, dreary, and wet. But unlike typical British weather, which tends to improve as the months pass, spring of 1816 brought endless rain. In Ireland, 8 straight weeks of rain wiped out nearly all the crops, while in England, the growing season was almost non-existent. But the wet spring was just the beginning. Summer proved to be even harsher. Frost ravaged Central Europe in June, decimating the food supply. In Italy, strange orange-brown snow fell during the height of summer. Spectacular sunsets painted the London sky with brilliant hues of green and red. By August, rivers were frozen solid on certain days, and the sun seemed to barely rise at all. The consequences were immediate and catastrophic. Widespread crop failures in Britain led to a doubling of bread prices. While few starved, it was only thanks to well-established maritime trade networks that Britain managed to import enough food to stave off famine. The year 1816 saw Britain importing more foodstuffs than ever before. From God's wrath to global panic. Editorials in major newspapers attributed the vanished summer to God's wrath, and church attendance spiked. However, things didn't improve much in 1817. Another round of failed harvests led to rural riots across the British Isles. Some historians even suggest a link between Tambora's effects and increased political radicalism during this time, climaxing in events like the Peterloo Massacre of 1819. Certainly, the failed harvests acted as a catalyst for unrest. However, Britain experienced relatively better luck compared to other countries, where the situation was far more dire. In Ireland, the widespread failure of the potato crop led to a devastating famine worsened by a typhus epidemic. Over 800,000 people were infected, and as many as 100,000 died. Central Europe faced a similar plight, with famine and disease gripping the region. In the German states, bringing in food became nearly impossible, earning the famine of 1816 the title of Europe's last major subsistence crisis. Italy too suffered from famine, but it was also plagued by apocalyptic panic. The Bologna prophecy, made by an anonymous astronomer, predicted that sunspots would engulf the sun and cause darkness by July 18, 1816. When a dark, cold spring was followed by an even colder, darker summer, many began to fear that the end of the world was near. In China, the unusual weather during the years 1816 to 1818 had a profound impact on the Yunnan province. These years were incredibly cold, causing the rice harvest to fail not just once or twice, but for 3 consecutive summers. With the Qing dynasty struggling to support its affected subjects, panic ensued. Countless people starved, and families resorted to desperate measures, including sacrificing their weakest members, babies and seniors, to survive. By the time the weather returned to normal in 1819, the people of Yunnan had grown weary of subsistence farming. They desired cash to prepare for future hardships. Almost unanimously, the peasants of Yunnan abandoned rice cultivation and turned to planting opium instead. This shift, sparked by a volcano erupting thousands of kilometers away, transformed Yunnan into the opium heartland of the world. Considering the significant role opium played in China's tumultuous history over the next 5 decades, this development must be recognized as a major consequence of Tambora's eruption. However, it was not in China but in India, where Tambora's impact affected the most lives, and not for the better. Around the Bay of Bengal, the weather in 1816 and 1817 oscillated between severe drought and monsoon seasons of unparalleled intensity. Unknown to anyone at the time, these extreme conditions provided the ideal environment for a new, highly infectious strain of cholera to emerge. Scientific projections indicate that if the Yellowstone supervolcano were to erupt, the consequences would be far more catastrophic than the eruption of Tambora. The scale of devastation would be staggering. The eruption would release an immense amount of volcanic ash, gases, and lava, potentially reaching heights of tens of kilometers into the atmosphere. The ash fallout would blanket vast regions, affecting not only the immediate vicinity, but also areas hundreds, if not thousands of miles away. The impact of such an eruption would be felt globally. The release of sulfur dioxide and other gases into the atmosphere would lead to significant climate disruptions, potentially causing a temporary cooling effect on a global scale. How far-reaching do you think the effects of Yellowstone's eruption would be? Let us know your opinion in the comments below.